if I can have your attention for our next speaker. He is a person with more than 25 years of experience in the IT industry, taking all kinds of roles from purely technical, from business critical, high-end ones. Today, he is here with us to give us his advice on a topic that I'm sure all of us have struggled at one point or another, and this is building effective diagrams. So it is my great pleasure to present to you Iancho Dimitrov.
Thank you. Thank you, Theodora. Hello, everybody. Nice to see you. I hope you're having a good time during the conference. I will not be giving advice. I will be sharing experience and trying to motivate you to get deeper into this area. So my name is Iancho, as Theodora mentioned, and first a little bit about my context. As she mentioned, I started as a software engineer, did almost everything within the process, like QA, architect, project program manager, then moved at some point to the dark side, started dealing with business, with sales, and currently at Musala, I'm responsible for business development, which means acquiring new clients and also strategic clients, making sure that they stick with us for 8, 9, 10 years in a row. So all the time, since the beginning of my career, I have here actually my mentor in my first development job at Etsy. Because we were a product company, we actually were designing our products. And from the very beginning, I was also engaged in coming up with ideas about the system. So I used diagrams from day one of my career. And I believe it's a really, really effective tool. It's also underutilized, and it's also not used the best way in most of the cases. So this is why I decided that I will do this talk. So diagrams have been around for a while. I'll just go through some examples that you might not know. So the Egyptians, long time ago, as you see, they were using diagrams to manage the process of building the pyramids. Our European ancestors, this bronze disc was found in the area where Germany is currently. So they were diagramming the stars. Also, Babylonians were diagramming the world so long time ago. This is how they thought the world looks like. Egyptians again with the stars. China, star maps. Arab people, again, interested in how lunar eclipse happens. And then some more recent and ones that I guess you know. So one of the most famous diagrams is Leonardo's Vitruvian Man, and also others like in Great Britain, a couple of centuries ago, when the cholera outbreak in London was a big issue. They were trying to make informed decisions about how they manage and isolate the areas. More and more looking like the current age diagrams. One diagram that is really, really famous, Mendeleyev's periodic table, although actually, in reality, originally it looked like something like this. And I would say iconic diagram that actually shows how a really complex and information-rich topic can be presented in a really, really effective way. So why care about diagrams? The good diagrams, they help understand complex systems in an effective way. Also, there is a saying that a picture is worth 1,000 words, and actually that a diagram is worth 1,000 pictures because of the simplicity, because the elimination of the clutter, focusing on actually what needs to be passed as a message. And yeah, diagrams are used to clarify, to send clear messages, to convey clearly information. So the good diagrams do this. Also, there are bad diagrams. This is why we should care, because if you need to make a diagram, and if you don't do it well, chances are something really bad can happen. So 3 quick examples. Ariane spacecraft, which exploded after takeoff. There were 2 teams. there were two systems that were communicating with each other, two software systems, and they were managing the flight. And actually, there was an issue with the communication between those two systems, and at the end, at the aftermath, with the analysis, it turned out that actually a diagram that was misleadingly presenting how the communication should happen was one of the things that helped this horrible thing happen. The same with Mars Climate Orbiter, which actually got too close to Mars and exploded. Then there was another issue. Then there were two teams that were working on the software, and one team was preparing some specifications and diagrams, and then the other team needed to build on top of them. And in one diagram, there was the information about how close to Mars it should go, things like this, and it was in miles. And the other team interpreted it as kilometers. And then what happened, that at the end it came closer to Mars and exploded. And with Fukushima, as you may know, Fukushima the Fukushima disaster was due to an earthquake and tsunami. But the thing is that there was time to try to react. And the operators needed to analyze the situation, consider what's the state of the nuclear reactors, and try to make them not melt down. The thing is, again, one thing that contributed, they needed to quickly analyze a lot of documentation, a lot of diagrams. Again, some diagrams had not really correct information and not really clear information so that they can make better decisions on what to do and maybe help not get into that big of a disaster. Ugly diagrams, there are also ones. I'll just click through some. I'm sure that many of us have been exposed to such and have seen this. Instead of simplifying things, just adding additional confusion. This is with a great name, Simplified NAS. And actually, when you see those diagrams that I just shown, like these ones and this one, I think maybe it comes to your mind that source code and diagrams sometimes, in some states, they have one thing in common. Does anybody? Yeah. Shout it out. That's correct. But I'm rather referring to this state of code and that. Who said it? All right. Great. I have a book for you for diagrams. Here you are. My pleasure. So, actually, the common thing that I was looking for is that they both, at sometimes, they come served with tomato sauce, parmesan, and parsley, spaghetti. Yeah, but still, why should one really care? So, one main reason, it's raining diagrams in the software world. So they're all around us, no matter what you do, QA, BA, developer, whatever, they are diagrams in requirements, in testing, in data, everywhere. So they are with us, so you'd better be good at doing diagrams. But why personally they are good for you? So first of all, they are good for self-support, for problem solving. If you are solving a complex problem, and if you start drawing and designing, not designing, but start drawing and diagramming the bigger picture, usually it helps you decompose the problem, it helps you find a solution quicker. Definitely improved communication. So if you can do good diagrams, you can pass more complex messages and more complex ideas more easily. This is related. You can sell your ideas in a better way. So especially if you want to convince somebody of something that he doesn't really understand, it's much better to help the message with some diagrams. Really important reason for me, it's a transferable skill. No matter if you're now junior, mid-level, senior, architect, top manager, whatever, or if you're doing QA or you're doing dev, diagramming skills will help you always. This means that if you acquire this skill, it will help you throughout the career. So those types of transferable skills are really important, according to me, for everybody's career, because you invest once and then you use it along the way. And last thing, no matter what you do, sooner or later you'll need to do diagrams. At some point of your career, you will do it. So all that said, I believe it's clear why should we care. And then 1 week ago, I saw this tweet. A guy that that saw the new feature of ChatGPT, that it can analyze graphic objects, and put this one of those diagrams that I showed you, and said analyze it. And it analyzed it. So actually, even a very complex or not really well done diagram, ChatGPT can help you. But why you do a diagram to explain something more clearly, but then use somebody to explain you the diagram? Still, I played with it. So I put it, I said analyze the diagram, certainly it responds and it provides you information, like 2-3 screens of information about the faces that are described, etc. But the faces were very short. I insisted, describe it in detail, each face. Again, detailed description. So it can do it. So I thought maybe I should actually recreate my session into a session how to use ChatGPT so that we can cope with ugly diagrams. But still, decided to move on. Actually, I think the more important thing is to understand how to make good diagrams that your audience would not need ChatGPT or somebody else to explain them. So this talk was delivered like half a year ago. For the first time, it was a 45-minute session, so it includes additional information that I will not be able to cover today, but still I kept it in the presentation, so whoever is interested can contact me after that via LinkedIn or email or whatever, and I will send you the information, which includes also the last part. So I will focus now on discussing what makes a diagram effective, and I will share you some practical tips about it, and we'll show you those tips through refactoring that we'll do together of a diagram. So what is a diagram? I'll just read this out loud. A visual representation of object systems organized and connected in a way aiming to explain in an understandable manner complex idea structures to a certain target audience. The important thing, target audience. So it is a good diagram is not a good diagram in general. A diagram has its purpose to convey a message to a certain audience. This audience has profiles, 1-2 types of people. They know this, they don't know that. They have those skills, they don't have other skills. So a good diagram is a diagram that serves passing the message in an effective way to this target audience. It might be not understandable by other people, but it's not a problem. The book that I just gave to the gentleman, actually on the cover has this picture. It's a simpler definition. A diagram is something that is visually represented and helps someone. I like it. So what are the characteristics of an effective diagram? So first, as I said, it should have a meaning. I mean, in many cases, people say, we need just to do a diagram of this, and start doing a diagram of this. So it should be clear what you need to explain or what you need to pass as information and to who. And this who has what characteristics. So intention and clear target audience are key. Clarity. Of course, everybody will say, of course, it needs to be clear. But saying to be easy to understand at a glance, it doesn't mean that you need to look at the diagram and to understand everything. Of course not. I mean, complex systems or complex concepts, they cannot be represented with a simple or like totally clear thing that you look at, you understand. No. But when you look at it, you should grasp clearly the bigger picture, and you should clearly find your way to what you need. So this is meant by clarity here. Simplicity, again, in the context of what I just said, it should be as simple as possible, but not simpler than enough to explain the complex topic that is with you. Consistency, extremely important. So there are so many cases where you see diagrams and you cannot orient yourself why those objects look the same, but they're different things, or vice versa. So consistency means that if you see something that is represented in one and the same way, like colors, borders, shape, whatever, font, then those things should mean one and the same type of objects, and vice versa. If you are representing like one and the same types of objects in different places in the diagram, they should be represented in one and the same way. So this is consistency, and it helps extremely when you look at a diagram. Readability, easily readable text. Again, this is a big, how should I say, a big, this stupid cliche, low-hanging fruit, because most of the diagrams, you have that big boxes, and that's small text. And yeah, so you should consider that it should be easily readable. So use the space and make sure that things look well, not only when you are zooming, but actually if you can read it on your screen, most probably it would be all right on everything else, on print and also on such a screen. So that's relatively the principle. Everything should be logical, so no room for interpretation should be there for anything that you see on the diagram. So if there is something that you take a look and you can interpret it and you can have, if you assume this, then this would mean that. If you assume something else that would be different, then it is not good. You should work on making it logical. And three more, quickly. So it should be visually appealing. That's actually nice to have, but at least should not be visually appalling. Because if it's visually appalling, like the ones that we saw, you get a rejection from the person that reads it. So you should be careful with color, symbols, etc. And you should take care of hierarchy and relationships to be represented in a, how should I say, proper way. So the logic of any hierarchy of the objects that you have should be seen, be it with size or inclusion, one in the other, etc. So those were the, let's say, 9 characteristics that I wanted to share about what makes usually a diagram effective. If you're good on most of those, then a diagram is usually effective. So now let's go for some practical tips. I will use a diagram that we created many years ago for a client where we did, it's a test automation diagram. So it is a diagram that we created for a German client where we were doing test automation POC, then first steps in test automation for them, etc. And then we moved to, it would be too much to say large-scale implementation, but significant implementation. So we had a proposal to make a sophisticated in terms of results achieved test automation solution for them that will help them remove a lot of manual testing and go for automated testing for quite a few systems that were living on top of a common platform. So we needed to clearly propose to them our solution, although we had also already their trust and convince them that we thought of everything and that actually the thing that we are proposing is very, very clear. So I'll use this diagram I should have showed to you, actually. This is how it looked at the end. So I'll take a previous version of the diagram that my colleagues worked on, and then when we were doing a few iterations of making it better, I will show the practical tips. But this is why the pause, so I'll just go back so that you're not distracted. I forgot to tell you something about diagrams, but anyway, it was a nice thing. I'll tell it to you about my motivation with the diagram. Sorry about that. It's a joke, but from life. So we were bidding for a project at a client, and it was an important client to win. We wanted to win it. There was fierce competition, 5, 6 companies. No matter what, long story short, we won the project. We did it extremely successful. And 1 year later, I had the confidence to ask the technical director, why you chose us, actually. And I asked him, was it the price? Did you like us, how we talked? Was it like the technical solution that provided? What was it? And you know what he told me? He told me, Iancho, you won't believe it. Out of all technical proposals that I received, and out of all technical diagrams that I received, yours was the only one that I understood. Not the one that I most liked. He didn't say I liked yours. He said I understood only yours. So coming back to the importance of diagrams. So we want a major client and a major project this way. So white space, extremely important. It can be your friend, it can be your enemy. Very much misused. In some places, people put a lot of white space that it doesn't add any value, and still they get objects too much together so that you can't see that they are actually objects. So this is the original diagram on top of which we will be doing the refactoring. So as you can see, there are a lot of white space that actually doesn't add any value, the green ones. On the other side, you see a lot of places where there is so much space that you actually can't figure out that those are separate objects. If you look the original one, do you see that those are like, say, four main building blocks of it? I don't see it. So this is the change that you can see, adding white space, how much easily graspable is the big picture. As I said, you don't understand it immediately, everything, but you start from the big picture and you can get deeper. Labeling and annotations. Fonts, as I said, as big as possible, not enormous, but big, so that use the space so that it is readable. Avoid abbreviations and acronyms. Think about what your target audience is. So would they understand this abbreviation? Would they understand this term, etc.? Diagrams is with limited space. So actually being concise and brief and still explicit without people thinking, okay, what is this? Without asking them to think, it's a challenge. So this is something that is hard to do, but still you should strive for that. So many examples. So here, as you see, system under test and environment, schedule and execution. As you see, those are titles of one and the same level of building blocks. But still, it looks like scheduling and execution is much more important. Then we have here the R2 test, R3, not really adding any value, because if you get into the details, you understand why. The same goes here. So instead of, those are too small on the top left side, tier 1 reports, defects. Why there? Why so small? This is how we changed it. So you see that now we have consistency. We have also the information here, not in the small labels, but with a much bigger one. And it's much more understandable this way. So third tip, and I'm taking care of the time also, size of elements, not bigger than needed. The bigger the elements you make, the bigger the diagram becomes, and the less readable it becomes. So in this case, you can see, for example, on the top left side, why this size, and especially of empty boxes, also why those are exactly this size. So what we did is we made it like logically sized in a way. Lines, extremely important. So people don't think that actually lines are a tool. So your lines, thickness, color, dotted, dashed lines, arrows, etc., those are tools that can pass a message. So looking at this one, again, the original one, all the lines are the same. Looking at that one, maybe you have not noticed it explicitly, because we saw it like 3-4 times already, but now you would mention that the major building blocks, the 4 major building blocks, the lines are thicker. It helps you. Maybe you just feel it, but it helps you outline the importance. So lines are something that you can use to make your diagram better. Color, background, font, again, extremely important tool that can help you pass a message. In our case, we didn't have that much to pass as a message, but still, if you see the original one, the titles here, they are hardly recognizable, especially on the top side. So what we did is the 4 blocks, the 4 major blocks, we made. So first, all, let's say, groups and subgroups. We said if it's a title, it will be blue. Then the bigger ones are with bigger font and all caps. And then you see the not the shadow, but the background behind. And again, you might not notice it like, okay, it makes a real change. But in general, if you feel this one, this diagram, is much clearer and much better than that one, the reasons behind are those things that we did as a change. So everything helps. A minute and a half. Alignments on elements. Here, actually, my colleagues did a really good job from the beginning. So even here, things are quite aligned. But yeah, there are still some things that can be changed. But in general, horizontally and vertically, everything should be aligned, just like in UI. As you know, it makes things much more easily graspable and easy to use. And the last set of practical tips. So every element, every detail that is on the diagram should be there for a purpose. So if something doesn't add value, just remove it. Use symbols and images. They are much more easily spotted, so you should make sure that you don't, let's say, overuse them. And they are much more easily rememberable, so they stick. And at the end, do a final review. So take a look at, okay, this is my release candidate of the diagram. Get whatever list, you can use my checklist, 9 characteristics. Can I do something better for this, something for that? So in terms of logic, because I'm out of time, I'll not get into, not out of time, but I don't have much time. I'll not get into details about applying the last tips. But again, things like, okay, why this is exactly with this elliptical form, it should be something special because it's the only one like this on the diagram. And you start thinking, and there is nothing special about it, really. So don't do it. If it doesn't make sense, like, don't do it, because otherwise you make the person think. So this is how it looked. So you do a final review. Does it fulfill the purpose? Our program manager, like on the client side, the program manager who is a technical guy, the architect, the test manager who was not exactly technical, will they understand what we propose to them? Clarity, can we do something else? Something else to help with clarity, with simplicity? So you challenge yourself, and if you feel comfortable, then I think you have a good diagram. So what you can get, as I said, from my presentation additionally, a step-by-step process about how to create a diagram from scratch, because we talked about applying tips on refactoring a diagram. Some resources, there are not many actually trainings for doing a good diagram, but still there are some. I will share links with you. There are a few blogs focused on diagrams, again, not many. There are a few books, just a few books that are published. Just contact me and I'll send you everything after that, no problem, no need to. This is the book that the colleague with the spaghetti got. And yeah, just link to some diagramming tools, but the tool is not that important. And also my recommendation on how to play and exercise so that you get better. So with that, I would like to encourage you to take diagrams a little bit more seriously than you're taking them today. If I manage to convince you, consider this, I will be happy. And yeah, the other thing is that there is, how should I say, a small step that you can do, and you will be shining twice as you're shining now. And chances are people around you will benefit from this and will actually admire your success. So thank you very much for your attention. I'll take a question.
Thank you very much, Iancho, for this very practical presentation. Unfortunately, we don't have time for questions, but Iancho will stick around, so go directly to him. I'm sure he will be happy to answer everything. And be back here in 5 minutes because we will have our final keynote, and it will be very, very interesting. So see you in a while.
Thank you.